بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 5.2 and it's about the definite integral. Let us define what we mean by a definite integral. If we have a function f and defined from a to b in an interval a to b, so we will define the definite integral of f from a to b by integral fb f of x dx equals the limit sum that we defined in section 5.1. So this is limit of Rn, but we are going to call it here Riemann sum. So this is the limit of the Riemann sum is the definition of the definite integral. So which means this is the area, of course, if you also remember, this is the area below the curve of f from a to b. So the definite integral is the area below the curve of f of x from a to b. So it is another symbol, okay, another symbol to use. This is called the definite integral. Under the condition that this limit exists and it has the same value for all possible choices of sample points, whether you choose the right end point or the left or the mid or any other point. If this limit exists, then we say that the function f is integrable on the interval a and b. So this is the definition of the definite integral. This is the integral sign, okay? A and B are the limits of integration. A is the lower limit, B is the upper limit. Dx is there, it's a symbol inside the integration, okay? And it means that we are integrating with respect to x. So x is the independent variable. The process or the procedure of calculating an integral, this is an integral, is called integration. The answer always of the definite integral would be a number. So in fact, this is a number. It could be positive and it could be negative. It's a number. It doesn't depend on x, which means you can write it f of x dx, f of t dt, f of r dr, all the same. Okay, all the same. This sum, which is inside here, which is this one, okay, is called the Riemann sum. The Riemann sum. Now, if f of x is positive, if the function is positive, then the Riemann sum will give you sum of areas of these rectangles. And the definite integral would be the area under the curve from a to b. This when f of x is greater than 0. But if f of x is a function that's sometimes positive and sometimes negative, then the definite integral is the net area. So we add these two areas and subtract this area from them to get the value of the definite integral. That's the net area. Evaluate the Riemann sum for this function from 0 to 3. So what is the Riemann sum? It is summation f of x I times delta x. Using n equals 6, so I here would be from 1 to 6. So evaluate the Riemann sum. That's the Riemann sum. Okay, that's the Riemann sum. Using 6 rectangles, 6 subintervals, and taking the sample endpoints to be right endpoints. So this is a function. And we have from 0 to 3. To find the Riemann sum, we first find delta x. We remember that delta x is b minus a over n, small n, number of subintervals or rectangles. B is 3 minus 0, so it's 3 over n is 6, number of rectangles. So delta x is half. Now, delta x is half, and I have x values from 0 to 3. So 0 plus half, half, half plus half, 1, 1.5, 2, 2.5, and 3. These are the 6 subintervals. We are going to use the right endpoints. So this sum would be equal to delta x, which is half, can be taken outside. Now, f of the right endpoints, f of half, plus f of 1 up to f of 3. The function is this function. So half times find f of half. Okay, you can use a calculator or find it. Half to the power 3 minus 6 times half. Okay, this would give you negative 2.875 plus f of 1. 1 minus 6 is negative 5 plus f of 1.5. Put 1.5 here. So it's 1.5 to the power 3 minus 6 times 1.5. So that's negative 5.625. F of 2 would be 2 to the power 3, 8 minus 12. This is negative 4. F of 2.5, it's 2.5 cube minus 6 times 2.5. This is 0.625. F of 3, 3 to the power 3 is 27, minus 3 times 6, which is 18, so it is 9. And now you add all of these numbers and you multiply by half and you write the answer. So this would give you an approximation of the actual area using the right endpoints. The answer is negative 3.9375. So that's the answer of the question. Now this is an important theorem. It says that If f is continuous or has only a finite number of jump discontinuities, then f is integrable on AB, which means that the definite integral exists. So the definite integral would be exist if f is continuous. Notice that all the functions or most of the functions we know are continuous. So always their definite integral exists, which means that the limit exists regardless which sample points to choose. And that's why we will always choose the right endpoints, because the definite integral will give you the same answer, even if it is left or any other sample points. So this would be the definition of the definite integral. Limit, this is the area using the right endpoints, where delta x as usual is b minus a over n, and xi as we know a plus I delta x. Question, express this limit as an integral on the interval from 0 to pi. So we need to express this as an integral. You need to concentrate here in the definition. Look, delta x becomes dx. F of xi becomes f of x. And the limit of the sum, the integral sign. So here I can write this. Limit sum, this is can be written as integral. From where to where? From 0 to pi. Then I need to write f of x. What is f of x? This is f of xi. So if this is f of xi, then f of x would be the same without I. So f of x is in fact x cubed plus x times sine x. This is f of x. And delta x, you change it to dx. So this is how we express the limit sum as integral. That's the answer. To evaluate definite integrals, we need some properties for the summation. So summation of 1 is n. Summation of k, where k is a constant, has no I, is k times n. Or you can take k out and you will have 1 inside. So you have n, so k times n. Summation I is this one. Summation I square, we have seen it in 5.1. And this is summation I cube. Notice that summation I cube is exactly the same as summation I, but raised to the power 2. Some properties of the summation, you can take the constant c outside. It's constant because it has no I. The sum distributes if you have plus or minus. So you can write it summation AI plus summation BI or minus BI. We need these properties, all of them, to evaluate the definite integral. So to evaluate this integral, I have to remember that the definite integral is the limit of sum I from 1 to n goes to infinity, of f of xi delta x. So the first thing to find is delta x. Delta x is b minus a over n. So it's 3 over n. There is no approximation here. We need to find the integral, which is the exact area. And now I need xi. Xi is a, which is 0, plus I times delta x. So it is in fact 3I over n. So that's xi. Now I need f of xi. Well, this is the function. So f of xi is xi cubed minus 6xi. Okay, but xi is 3I over n. So I need to find f of 3I over n. It would be 3I over n cube, which is 27I cube over n cube minus 6 times 3I over n, 18I over n. So the Riemann sum would be summation from 1 to n f of xi, which is this one, times delta x, which is 3 over n. You can take 3 over n outside, and I will multiply, distribute. So multiply 3n times this. So 3 times 27 is 81 I cube over n cube times n is n to the power 4 minus 18 times 3 is just 54 I over n times n, which is n square. Now I can distribute the summation this minus summation this. So I will do that, and I will take the constants outside. So I have 81 over n to the power 4 times summation I cube from 1 to n minus, I'll take 54 over n square outside because it's constant times summation I. Now I use these formulas, okay, for summation I cube and summation I square. So it would be equal to 81 over n to the power 4. Summation I cube is n times n plus 1 over 2 to the power 2 minus 54 over n square times summation I, which is n times n plus 1 over 2. You have, or we have 2 square here. So it would be 81 over 4. 2 square is 4. And I have n square here and n to the power 4 below. So I will have n square in the denominator, cancels with this n square, and I will have n plus 1 to the power 2 in the numerator. All right. If you distribute the 2, okay, you have n square cancels with n4 and n plus 1 square minus 54 over 2, that's 27. Okay, 54 over 2 is just 27. And n with n square, so I will have n in the denominator and n plus 1 in the numerator. And now finally, I can find the definite integral by taking the limit when n goes to infinity of this quantity, which is 81 over 4 times n plus 1 square over n square minus 27 n plus 1 over n. Now, when we take the limit, when n goes to infinity, we take the highest power. The highest power here is n square. So n square over n square is 1. So I will have 81 over 4 minus. The limit here when n goes to infinity is also 1 because n over n is 1. taking the highest power. So 27. So that's the definite integral 81 over 4 minus 27 will give you the exact area, which is negative 6.75. You remember the approximation? We found the approximation here, negative 3.9, and the exact area is negative 6.75. So the definite integral is negative. This means that if the function is not positive in this interval, I mean, part of it positive, part of the function is negative, and when we subtract the two areas, we get negative 6.75. Set up an expression for this function as a limit of sum. Okay, again, we will use the same rule, which is integral from a to b f of x dx is the limit when n goes to infinity, summation I from 1 to n, f of x I times delta x. So what is the question? Set up an expression for this as a limit. That's it. What is the function here? The function is e to the power x. Okay, so what is delta x? b minus a, 3 minus 1, which is 2 over n. Good. And what is xi? Xi is a, which is 1 plus I delta x, 2i over n. Good. What is f of xi? E to the power xi. So it is e to the power xi. Okay. We don't have to write this. We can immediately uh, replace xi by its value and find f of 1 plus 2i over n. So it would be e to the power 1 plus 2i over n. That's it. So I can write integral from 1 to 3 e to the power x as dx as express this integral as a limit of sum. So it's limit when n goes to infinity, summation from 1 to n, f of xi, which is e to the power 1 plus 2i over n, times delta x, which is 2 over n. You can take 2 over n outside or leave it inside the sum. Both are correct. So that's the answer. Evaluate the following integrals by interpreting each in terms of areas. Okay, this is not easy to solve because it's not like also this is not easy to solve. We cannot find the limit here. Okay, that's why we are not asked to find the limits, but evaluate when we have a polynomial, power 1, power 2, power 3, but square root we cannot do that. So what should we do? We can use graph. We can graph the function f of x. This is f of x, which is y. So y is square root of 1 minus x squared. If you square both sides, then y squared is 1 minus x squared. And if you take x squared to the left-hand side, then you will figure out that this is a circle. Circle with center 0, 0 and radius 1. So, but we have y equals positive. So this is the upper half of the circle. But it's from 0 to 1. Okay, so it's from 0 to 1 only. So he is talking about this part, this portion. Okay, the question, what is the integral of this root? Which means what is the area of this region? So integral from 0 to 1 square root 1 minus x squared dx is exactly equal to the area of this region. Well, the area of this region is 1 over 4 of the area of the circle. What is the area of the circle? Pi r square, and r is 1. So it is pi. This is the area of the circle. So the integral from 0 to 1 of 1 minus x squared dx would be pi over 4. That's the answer. Another example. Now this is a straight line. I can solve this question using the previous method, this method, the usual one, this one. And please do that at home as an example. But here he needs me to use the area. Okay, so I'll graph the function and try to find the integral using areas, the area. So from 0 to 3, okay, 1, 2, 3, from 0 to 3, this is a straight line. If x is 0, then it is negative 1. So this is a point. If x is 1, it is 0. If x is 2, it is 1. If x is 3, it is 2. So that's the line, okay, in this interval from 0 to 3. And we need to find this area, this area. This area is positive. So minus this area minus this area will give you the value of the definite integral. So how to find, let me call this A1 and this A2. So the definite integral would be A1 minus A2. Good. What is A1? This is a rectangle. The area, sorry, yeah, a triangle. The area of the triangle is half times the base. What is the length of the base? 1, 3, 3 minus 1, 2. So half times the base, the length of the base, which is 2, times the height, the length of the height. The height is also 2 because from 0 to 2. So the answer is what? 2. So A1 is 2. What is A2? A2 is the area of this triangle. Well, again, it's half times the length of the base, which is 1, the height, which is 1. So 1 over 2, half. So the area would be 2 minus half, which is 3 over 2. So if you use the method of limit sum, you will find that the area or this definite integral is also 3 over 2. But here we found the value using areas, using the graph. These are some properties of the definite integral. If you change the limits, BA, if you write it AB, you multiply by a negative sign. Okay, so from B to A is equal to minus from A to B. If you find the area from A to A, this means there is no area from A to A, nothing, 0. The definite integral would be 0 because delta x would be A minus A, delta x would be 0. So the definite integral would be 0. If we have C constant here, constant with respect to x, because this is dx, so you should have x inside, but I have C which has no x, so the integral would be, the definite integral would be C times B minus A, the difference between B and A. So that's a formula, okay? And it's easy to prove because y equals to C is just a horizontal line. And if you want to find the integral from A to B below C, so you mean you need this area. This area is the integral from A to B of C dx. And the area of this rectangle is B minus A, which is the length of this side, times C, which is the length of this side. So it's in fact B minus A times C. You can distribute the integral with plus and with minus, and you can take C, the constant outside, if it is multiplied by a function. Notice the difference between this formula and this formula. Here C alone without X, so that's the answer. Here C is multiplied by a function, so you can take it out and you evaluate the integral of the function. The last one, the integral of f of x from A to C is the integral from plus the integral from C to B is the integral from A to B, which means you can distribute. And if you want to find the integral from A to B, you can put C here in the middle, find the integral from A to C plus the integral from C to B. Okay, it will give you the same answer. It would be this area plus this area, so you will have the same answer. So these are properties of definite integral. This is an example. It's known that integral from 0 to 10 is 17, from 0 to 8 is 12. Find from 8 to 10. Well, from 8 to 10, f of x dx would be from 8 to 10. I can do it like this. Okay, I can say that integral from 0 to 10 f of x dx equals integral from 0 to 8 f of x dx plus from 8 to 10, using this, the last property, this one. We have this, it is 17. We have this, which is 12, and this is unknown. So this integral would be equal to 17 minus 12, which is 5. So that's the answer. And that's the end of the lecture. Have a nice day or night.